I know, how are you? Okay, we'll get started in about 1 minute. If you want to download your notes and your assignment for today. Okay, I'll go ahead and get started. So today we are going to cover 2 chapters. Part of chapter 10 we touched on a little while ago, and we're going to lead into chapter 11 later on. So as in the prior weeks, we talked about threads. This is to follow up to be able to implement data structure with threads. So I wanted to touch on chapter 10 first, and then we'll go through chapter 11. So in chapter 10, it begins talking about threads and thread of execution. And so a thread is a smallest unit of programming command. So it is a programming command. And or it could be a code that a scheduler can process and manage. So in the past, we had talked about how we can create thread pool. And this week we're gonna go into the breakdown of what threads are and how to implement thread effectively. And this can be useful to your project. So a thread is an element of a process. And we can have more than one thread per process. So in some cases, we might want to implement multiple threads for our process. And in the prior week, we touched on what a process would be and how we would use a process pool or a worker pool. Now, as we continue with concurrent programming, we want to think about how we are utilizing resources, and as we know that threads use shared memory. So unlike processes, threads, we would pull the data from the same location compared to processes where we would use distributed memory, one location per process. So when you're working with thread, you have to think about how thread uses the same resources. So that means that if there's a hang up on one thread, the others that are waiting will not be able to complete. And we will talk about how we can lock threads and be able to handle some of the issues or the errors, exceptions related to thread. So as we know that we can have multiple threads per process, we can have threads that share the process, and we would implement the instructions or the code and the context as in referencing the variable to be able to access the threads. So we can also treat threads as independent component. So that means that they can work together or they can be individual in computation like a process. So it's really how you want to design your program and implement your program and think about how threads can be used. So as we say that we can have multiple threads per process, we can also treat thread as individual component, and we can also use those in the shared data space. So here it gives you the visualization. We have thread 1 and we have thread 2, and these two threads work together in one process. And we would look at those to be able to concurrently apply them so that way they can improve our execution time. So that would lead us into the next part, which we talk about multi-threading. And so to define multi-threading, we have to understand what a single threading is. So a single threading is a sequential processing. It's going to execute one or a single command at any given time. So when you're using a single threading technique, that means that it only execute one command at a time. Where we would have multi-threading, we can implement one or more threads in a single process simultaneously. And in this picture, you can see that we can have thread 1 and thread 2, and they can be executed. Both of these commands can be simultaneously executed in one process at the same time. So in a single processor, we can implement multi-threading by using time slicing. And this is a way that the CPU would be able to differentiate what threads are running. So when you slice the time, what's going to happen is the processor is going to switch the execution between the threads, and it's going to create a perception of parallel execution. So it can start with thread 1, and then it's going to pause, and then it's going to go into thread 2 and finish thread 2 and then come back to thread 1. So in that sense, what we see is that we would simulate, or we would give a perception that it is executing both threads simultaneously. But remember that it started out with the single threading. So ultimately, you can only execute one command at a time. But instead of completing that command or the instructions, it's going to switch between the two. And depending on which thread is going to finish first, we can start both threads together. And we saw this before where we use the start method, and we would be able to have the thread 1 on pause, finish thread 2, come back to thread 1 and be able to complete the process. So it is a way that we can execute things quickly, and we would give a perception of parallel execution. So another visualization that you can see is like this. So we would have task 1, task 2, task 3, and it's going to slice the time for task 1, and it's going to complete task 4 while it waits to complete task 1. And then it's going to also continue with task 2 and 3 and so on. So in that time window, when we do this, we actually do save some time. And it really depends on what type of task that you're trying to incorporate. right, for that particular process. So this is a way that we can think about how we can implement multiple threads for our process using our processor. Now, for the multi-core processor, each core can execute the thread simultaneously. So in that sense, we would actually take advantage of our multi-core in our multiple core processor. So when you slice this, what happens is it would dedicate the core for individual tasks. And so while core 1 is handling task 1, it's going to slice while core 4, for example, is going to tackle task 4. So you do see that we would be able to improve the execution time, and we would have a perception of parallel execution. So now in time slicing, if you're using one single core, and this is traditional, right, processor, you don't see that many processor around that has single core anymore. But in the case that if you're using a single core, this is not recommended as the time slicing needs to be switching between tasks. So when you implement multi-threading, you have to think about the hardware capability, its specification, and how you can maximize the multiprocessor capability in handling your threads as parallel processing or concurrent programming. So we can say that ultimately, when we implement multi-threading, we learn that it is going to give you faster execution time. And so each separate thread in the same program can be executed concurrently or in parallel. So that means that we can shave off time or improve our execution time. It also provides responsiveness. So as you are treating individual separated the threads, each of the user inputs can be implemented simultaneously. So you might have multiple types of inputs, and that can be handled simultaneously. So the responsiveness is going to come from how you can use the threads for the input purposes. Therefore, when we think about things that needs to be responsive, like servers, databases, web-based structure, what we can think about is how we can design our program to be able to address the need for our system to communicate, right, effectively, or your program to respond to the users effectively. And compared to multiprocessors or multiprocessing, what you can see is because we are sharing the same location, right, we are minimizing the amount of resources that's being used. So in comparison to multiprocessing, your threads share the same location, so you don't have that many resources that's going to be utilized compared to multiprocessing. And then even if you have different requests and need to access data concurrently for your single threaded program, that would lead to a faster communication or more efficient communication between the threads, as it would just fetch it from the same location. Now, as we learn about the advantages, we've got to talk about the disadvantages. So when you implement thread, there is a risk in crashing. And whenever crash occurs, it's usually is because there's an illegal operation. So if all the threads in the process are utilizing the same resource, there will be a hang up or some form of crash. And that can cause the program to either become non-responsive or it goes into a halt. So we would see a crash of the program. Then you might have synchronization issue, in that when the threads are coordinated, because they are systematically accessing the data, and so it is harder to manipulate how the data can be computed. So therefore, in the synchronization on how data computation can be implemented, you would see that there is some issues in how thread coordination can create deadlocks, which we'll talk about later how to handle this, live locks or race conditions. So you don't want these things to happen. And so therefore you would need to handle these things when you are implementing your threads. Okay. So these are some of the things that you should consider when you're doing your project, when you're choosing your options, and whether you want to use multiprocessing, multithreading, or in future programs that you are going to write in Python. So let's come back now to our assignment. Let me come back up to the top. The first question asks you to describe the differences between thread and a thread and a process. So we can say that a thread is an element of a process, and you can have more than one thread per process. They can be executing concurrently. They can share or access the same resources, such as memory. And as threads are threads in the same process shares the instructions on the code, the context, which are the values of the reference variable, can be used at any given time. So therefore, you do see efficiency in how the resources are being used with threads. So in between the threads, it would just reference the values or what is stored in the variables. Then we can say that thread is an independent component. We can treat it like an independent component of computation, like a process. But threads within a process can share address space and data. So when we look at this, we can say that we can implement process that would entail multiple threads. And as we do that, we do see some efficiency in time and resources. For question 2, it asks you, what is multithreading and how is multithreading different from single threading? And in the notes, you see that by definition, single threading is a sequential processing executing single command at any given time. So that means that it's only one command. Multithreading, we can implement one or more thread, and as more than one thread can be used, it's able to execute the command simultaneously in a single process. Any question on number 1 and number 2? So for 3, how is time slicing used in multithreading? We can say that time slicing is a technique that allows the CPU to switch between different software running on different threads. In time slicing, the CPU switches its execution quickly and often creating the perception of parallel execution. So the difference in the switch for time is going to be minute. So we would not notice the difference when we time slice. And when we implement multiple threads, right, we want to use time slicing. That allows us to have parallel execution. Any question with 3? And you can find this information on the first page and the second page of our notes. So again, we don't have to put it verbatim. We can summarize it The whole point in this is to make sure that you remember and understand the concept. Then for 4, we want to describe how multithreading is implemented using multi-core processor. So when you're using multi-core, which is your current modern day processor, each core will execute each thread simultaneously. So if you have 8 core, right, we can use each core for our threads. And the separate threads in the same program can be executed concurrently. So the 8 core will be used for 8 threads, and they will be executing in parallel. Now, or in parallel if they are sufficiently independent. So if you have 8 core, and if you have, let's say, 2 threads per process, you're able to execute multiple processes as it would complete the task per thread more quickly. Any question on this? And in the notes, it also talk about your advantages and disadvantages. So we know that threads will cause crashes. Okay. And so crashes just means that there's illegal operation within a thread, and that would affect the processing of other threads. For synchronization, the issue with synchronization is that threads must be coordinated. And so therefore we have to plan out on how we utilize the threads in a systematic manner, so that your data is computed and will produce the result accurately. If there is issue with synchronization, usually the cost of it is that the threads coordination is not appropriate. So that will cause deadlock, live blocks, and race condition. So that means that you could have a thread that keep using, or it never finishes, and that will cause the delay in the rest of the threads. Any question on the assignments and notes for the first part? Okay. So for the answer for that question number 5, you can find that on page 2. So now I clipped this example and I wanted to show you that we can, and this is not a complete program. So even if you run this, you won't have any output because we didn't call any of the functions in the main. So this is only a snippet of the program, as you can see. So here, this program start out with importing the module. So we would have threading, and we would use time to measure. And the first part, starting with line 7, you would see that we would define a class, which is called myThread. And the intention for this class is to really create threads that would be used for tasks. So once we define our class, and we want to pass threading that comes from the module here, And we're using the module superclass, which is thread. Okay, so we're pulling the superclass from threading. And you would have an init function. This is, in Python, we would use this like a constructor. Okay, so you would instantiate the components of your class this way. So with that, what we would say is that because you're using init function here, and because you're using the module, you have to continue it with saying that you are going to also define it, you're going to instantiate init from the module. So you would say threading.thread and then .init, and you want to pass self. So the self here is simply just a placeholder, right? And you know, usually in the industry, they would use the self, but you can use any identifier, and that's just going to be like, it's going to fill that in later. So as you pass the self here, right, for the members, you want to say self.name is name. So these are like the member variable. And then delay is delay. So now, my practice, we should use an init function. And then we would go to the next part in which we would define the second function, which is going to be the member function of that class. So here we would say def run, and this is another function that for this class, and we would pass the self, and simply we're going to print, and we're going to say starting thread, and we want to pull down the thread name, and then the thread countdown is a method that is pulled from threading. So we would say thread countdown self.name self.delay. And that was previously defined in the init. Then we're going to print finish thread and self.name. So this allows us to see, right, which thread and which one is going to be delay or pause. Then the thread countdown, sorry, I mentioned it was pulled from the module. It's actually defined below. So thread countdown is the next function, and then you're gonna pass name and delay, and we are gonna count. The counter here is gonna be the number, right? That we would use in our loop. So your counter is gonna be 5, and it says while counter, we're going to have a delay. So we have a pause here, and this is how you slice. Time.sleep, delay. Okay. And then we're going to do the countdown, pass name and counter. So as it goes down, it's going to subtract 1. So we start with 5, 4, 3, 2, 1, and so on. So that means that we have to decrease on the counter. Okay, so this snippet shows you on how you can write or begin to write, right, a multi-threading program, and you would have class and objects and be able to implement member functions in the program. Okay. So here it gives you the step breakdown on what had happened, right, inside that snippet. Now, threading is a package that comes with your Python package. So, and you can go to the documentation. Okay, so if you click on that link, it's going to take you here. And now they do have, if you pull this in your IDE and if you search for threading, there are like other alternative threading libraries that you will see. So this is going to be supported with version 3.7 and later. This was originally implemented for Python 2, but now going to be used in the change version 3.7. So they're saying that they do have some support with the Python 2.5, and it says, you know, some of the names and method functions were deprecated for Python 3.10. So as different version of Pythons are used or created, what you can see is that you would have some methods that went away. So it's always good to go and look at what is updated. You know, like let's say a year from now, if you want to use this library, you should always go back to the documentation because your version of Python might be affected. So you want to make sure you look. And if you use it with CPython, then we're going to talk about, we talked about GIL a little while ago. We're going to come back to GIL. So because of GIL, then your thread executed is all at once, and it talks about there's limitation that needs to be overcome. So for some of the methods that's used in this is going to be listed inside this documentation. So you can take a look at the functions that's supported for threading. Okay. And so on. Okay. So there's a link on page 3. And so now we're going to look at a simple program, which is example 1. And this is a very easy program to write, as you can see. It's simply we write 2 threads and then we just start and join. We've seen something like this before. Okay, so let me clear this so you can see the start. Okay, so we have an import statement. We can say from my thread, import my thread. Now, my thread is another Python file. So it is another Python file that has code here. So without this file, example 1 will not run. Okay, so it is a module that I'm importing in. And so we will look at example 1 first, and then we'll look at my thread. Okay, so in the example 1, we simply create an object called thread1. And this is an object of my thread, which comes from the other file. And for it, we would say that for the parameter, we would say A, and then 0.5. Second object, thread2. This is an object of my thread, B, 0.5. And we would start both thread. That's going to begin, right? It's going to initiate those threads. And we talked about join method before, so it's not going to, it's going to make sure that it's not going to allow the other thread, the first thread, to finish. So when you join it, you want to make sure that, you know, that can get complete before the main. And then lastly, we want to print finish. Now let's look at the my thread. Okay. And you saw a little snippet of this earlier in our example, right? This is the same thing. We have the class. And so when you import in the module, it's going to look at this file, right? And it's going to execute part of this file as it goes through. So basically, this allows us to create or use the function for our threads here. Okay. And the name is A and B, as you can see, and the delay is the value 0.5. Okay. So we have the function run, and that's gonna print, right, our A, which is our thread A. Then we call on thread countdown, which has a counter in the while loop. And then that's going to apply the time delay. Then we're going to print again the name AB. Okay. And then for the thread countdown, we touch on this. We implement the while loop, and this is going to do our pause for the slice. So as we start those, right, it's going to use this file to be able to run because the class is specified here. Okay, so we're going to go ahead and run this. Sorry, I'm trying to pull up this part, but okay, so it tells me that I'm starting thread A, starting thread B. Okay, and we are going to do the countdown. This is where the while loop comes in. We're going to do thread B countdown 5, thread A countdown 5, and then thread B countdown 4, thread A countdown 4, and so on. And it keeps doing that. And we decrease as we proceed with the loop. But when we get here, okay, when we get here, thread B countdown 2, thread A countdown 2, thread A countdown 1, and thread A reaches 0 first, so it's finished first. Because of the join, right, finish won't pop up until after thread B is complete. Okay, so then we're going to have thread B countdown 1 as it decreased down to 1, and then it got to 0, so it finished. And then you would execute the part in main, which is going to be print finish at the end because of join. Okay, so as you can see, when we look at it this way, we're actually seeing both threads are being executed simultaneously, right? 5, 5, 4, 4, 3, 3, 2, 2, 1. And at one point, one of the threads going to finish first, and then the other thread's going to finish after that, and then it's going to finish out your main part of your program. Okay, and it simply implemented the delay in the 0.5 of the second, and that's allowing you to slice. So here we do see the slice because it could go thread B countdown 1 after thread A countdown 1, but it sliced it, and so thread A completed before B. Okay. Any questions? Okay, so that's one example. Then I also put down the information. This was also provided in your book. So you can also use start, you can use run method. We touched on this before. So when you use the run method, it needs to terminate. We can also check which thread is still running by using is alive. And then, of course, in this particular case, we're using join method that blocks the calling of thread who's joined the method, so that until they finish, until they're terminated, then it's going to continue on. Okay. And if you give it a name, like what we've seen in the parameter, that's going to be passed to the constructor. So it's going to read it as a name attribute. And that's what you see in the example 1 program. So if you put it in all together, right, in the next example, what you can see is that what we can do is we can implement a lock by creating a lock object. Okay, so on page 4, if you take a look at that screenshot, there on line 27, you see a thread lock, and that is a lock object. And what that does is going to lock the thread. Okay. So if you write it as a one complete program, you would create your class, your member functions to be able to use name to display your thread name and then apply the delay. But you at one point you need to make sure that you lock the thread because you don't want illegal operations or crashes. So here is where you can apply the lock. Then your thread A or thread 1 and thread 2 is the same. We have it called A and B, and then use 0.5 of a second, and then you start your thread. Okay, so this is how you can apply the lock for your threads. Okay, so for number 6, it asks you, when using threading module, which functions return the number of currently active thread objects in the program? Which function returns the list of all the currently active thread objects in the program? So you can go to your documentation and look up your functions, but ultimately you will find that using active count, and it needs to be typed this way, from threading module, you're able to identify the currently active thread objects. This is a way that we can track our threads. And then you can also use enumerate, and that's going to give you a list of the currently active thread objects. Okay, so these functions might be useful if you're trying to be able to track your threads throughout your program. Okay. Then for 7, it says refer to notes in chapter example to create a new thread using threading module. Define the class new thread that implements threading module and instantiate 2 members, var1 and var2. So we're not going to write the complete program. We're only going to write the class part. The reason why I'm doing this is I'm showing you how you can create a class for your project used for threading. Okay. So in the second part, you can use the screenshot as example, but that's really easy. Above your class, of course, you gotta import in your threading and time. So that's needed, but I'm only gonna cover the class portion. So you would have class, and then by practice, we want to use capital for our class name. So I would say new thread, and I'm using the threading module. So, and it's superclass. So I would say threading thread, threading.thread for the parameter. And I would begin with the init function. So we would say def, right? Init. And since we're passing var1 and var2, you would say self, comma, var1, var2 for the parameter. So you have 3 parts, the self and your member variables. Then to instantiate your member variables, you are going to, for the next line, you would say threading.thread, right? Because it is an init function. So here we would need to implement this line or write this line to add the init from the library. So we would say threading.thread.init and then pass the self. then we would define our member variable. And we would say self.var1 is var1. Self.var2 is var2. So whatever variable name that you use, right, you got to make sure that it is included in your parameter for the init function, and then you are going to define it with the self dot. And this is a simple practice in writing classes in Python. As some of you already took 30A and you've seen this before, but if you haven't done this before, this is just going to give you the basic structure. And then after that, I can define additional function. Now, Python doesn't always require your init function, but especially when you're using packages and libraries, or packages or libraries, you should, and when you define a class, you should always use init function. Okay, and that allows you to construct, right, objects and, you know, members, variables, and member functions for, you know, whatever the purpose of your program would be. Any question? Okay, so fairly easy. Use example from the notes, or you can see here. All right, so for the next one, this is example 2, and you've seen a little bit of this before, but this is to compute prime numbers, right? So in this particular example, we are using multi-threads, and we are going to implement the function for is prime. Okay. All right. So let's. Okay, so in this one, using threading library, we are also going to use the math library because there are operations that we need to include for our prime numbers. Then we have a function called is prime. It's going to pass for the parameter. We're going to pass x. And we're going to check if x is less than 2, it's going to print not a prime number. And then we have an elif. If x is equal to 2, then we're going to say it is a prime number. Then elif if x mod 2 is 0, no remainder, then it is not a prime number. And then lastly, the else, we have a limit, right? If you have written math equations or formula for prime numbers, you know that we put a limit. So your limit, we're going to parse it with integer. We're going to square root the x plus 1. Then we have a for range. Okay, so for its parameter, it's going to be 3, limit, and 2. If x mod I is 0, which is your index, we're going to print not a prime number and return. And then lastly, for this, we want to say print, right? Your index is your prime number. Then following, we saw this from the last example. We have a class mythread that's using threading module superclass. And then we have an init function, self, and we're going to pass x. In this case, it's only x because that was used here in the prior function. And then we do threading.thread in itself. And then we would declare our member variable or instantiate it. That will be x is x. So self.x is x. Then we would do a run. So there's a function called run. We just pass the self. And then we want to print starting processing. And then we would call is prime, which is the first function that's defined, and pass self.x. Then we have a list of input. So we would say my input to 193 and so on. Now here is your container for your threads. So it is a list. And we're going to loop. So as it handles the input, right, we want to say for x in my input. And we would have our object called temp thread. It is going to use my thread class, which we define, and we're going to pass x. And we want to start each of the thread. So we would say temp thread.start. And as it does that, it's going to append it into a location. So threads append temp thread. As it is a group of threads that we started, we got a loop and then join. So you would say for thread in threads, and then you would have thread.join. Okay. And then lastly, we're going to finish. So it's going to wait till all the threads complete, then it's going to go here. Okay. So it tells me that starting process 2 is prime number, right? That was the first value here. Starting process 193, which is the next index. 193 is a prime number, so it checks the condition from the function that we defined. And then the next one is 323 is not a prime number. Starting the next one, 1327, it is a prime number. And then the last one on the list, and it is the prime number. So it's finished. It seems like it is sequentially going through, but it's actually doing this, right, as it loops through. Now we didn't slice here. So if you can implement time slice, so you can, handle the longer ones last, and then, let the faster one go first. So what it's gonna do, it loops through each of the thread, and then it's gonna, when we have a lot of input. So imagine that you might have hundreds of thousands of input. It would be more ideal that you would write threads to be able to handle the inputs. Okay. All right. So here in the earlier questions, we saw the questions about your functions, and these are only a few that I included in the notes, but you can always go to the documentation and find the information. So your active count, your current thread, your enumerate. You can also use this function to look at your current thread control from the caller. So threading module, they claim that it is user-friendly. And so you should treat each of the thread that is created as objects. And we saw this in example 1 where we see thread 1 as an object, thread 2 as an object, right? So the way that we use the module is that each thread is an object. And similar to what you've seen in the prior chapters, we have run, start, join, is alive, get names, set name, and so on. So these are the methods that can work with your threads. So the steps in creating the threads are, you need to define your subclass. And when we define my thread, that's actually a subclass, and that class is going to access the superclass threading.thread. So this is a superclass from threading. And then you are going to do the init function. This is going to override the default method inside the subclass. And you can add your custom argument like X, var1, var2, etc. Then we can also override the run by default inside the subclass. So you can modify how your thread is going to be started and joined. So we would use start and join instead of run. So those are the three main things that we should think about when we create threads for the program. Then the next part, it talks about synchronization. So earlier we said that thread have issues with synchronization. This is a concept that looks at the mechanism to make sure that no more than one current thread can process and execute at a time. Okay. So it's dedicated to one thread, and this, even if you slice, right, you actually pause it and then go to one thread and execute that one, and then come back to the other thread and execute the other. So that means that if no more than one current thread process can process and execute a particular portion of time, this is starvation, or it also known as critical section or race condition. So as for critical section, the other threads must wait until the first one finish. Okay, the one that was executing finished. So when you run into critical condition, your program hangs. So we want to avoid those problems to make sure that we have it synchronized appropriately and coordinate our threads appropriately. And so that allows us to have accurate results, so you don't have discrepancy in your data as multiple threads are accessing the same location where your data is stored. Okay. So now we're going to look at the mechanism that allows us to do that. You saw this earlier with lock. So a common way that we can apply synchronization is through locking mechanism. And so and they already implemented this in the library, so you simply can just use it. So you use lock class from threading library. And you can simply create an object that is a lock by using this class. So with that, we can use a method called lock, and that would initialize and return a new lock object. So that would block, right, the others from accessing the locations, and then it's gonna allow the program to, your thread to finish. And so when you use acquire for blocking, when this is called, all threads can be synchronously running. That means that only one is going to be executing the critical condition section at the time. So that would put it into the sequential mode, which is going to let one thread finish before it goes to the next. So for the argument for blocking, we need to specify whether the current thread should wait to acquire the lock. So what goes here is the wait or not. So if you don't want the wait, it's going to be 0. If you want the wait, you put 1. Okay, so that will go here for the wait or not. And then once we're finished with the lock, we would need to release it. So you would use the release method, and that would allow us to release the lock. Here's the screenshot for example 4. So same program that we've been seeing. Right? The first part, pretty much the same that you've seen before from the beginning. And then our thread count down function. We saw here's the lock object. So you can call it anything you want, but for this one, they use thread lock as the name for that object. And it is a lock object from threading. And then we saw the thread 1 and 2, created and start and then finish. So by applying this, right? Let's run this and see. So you saw earlier where we didn't have the lock when we ran this program. Okay. Now, when we apply the lock, it's still going to start A and B together because we have the start here. And then we are going to have thread A begin with countdown. So it's going to loop for A, 5, 4, 3, 2, 1, and then finish. So it's going to lock for the A. It won't let B go. So unlike the other you saw earlier, the A and B are together, right? And then you have thread B loop, and it finished thread B, and then it finished the program. Okay, so in this way, we force the thread to be sequential by using the lock mechanism, okay, while the other kind of waits. So if the concern is going to be how your data output should be more accurate, then you should consider applying the lock, because if thread B is accessing the data location to retrieve the data that is not finished by thread A, you will have discrepancy. So let's say that my thread A, I need to process some values, right, output. And as I complete that, right, I can use that value for thread B. Well, if you don't lock it, thread B is going to retrieve the data that is incomplete by thread A, and you will have inaccuracy in data produced for thread B. Okay, and so this is why we use the lock mechanism. And when we looked at the prior example, yes, you can have them execute concurrently, but if your concern is going to be how your output would be accurate, then think about using this technique. Any question? Okay, so let's proceed with number 8. It says using threading module, identify the methods that are associated with the below operations. You can find this in the notes as well. So for 8A, returns the name of the calling thread, that will be getName. So again, some of these methods can be used to track or start and making sure that your thread's running appropriately. So getName gives you the name of the calling thread. For B, begins initialize calling thread object by calling run method. So we know already from the prior chapter that it's the start function. So this function allows us to use run in the back. Then for C, it waits for the calling thread object to terminate before continuing to execute the rest of the program. That is join. And we saw this, right? Finished with an ED, complete goes last because of join. So all the threads must be done when we use join before it goes to the next part of our program. Is executed when a new thread is initialized at the and started, so that is run. Okay, so when you start, it actually execute run. And then for question 9, it says, what happens when a thread is accessing or executing the critical section of the program? So in the critical section of the program, we want the other threads to wait until that thread is finished. And we would use the lock for that. Okay, so we would need to hold off the other thread. So the other thread must wait until the executing thread is finished. Then for 10, it says, what is the primary goal of thread synchronization? To avoid any potential data discrepancy when multiple threads accessing their shared resources. That is the location where the data is stored. So as we share that resource, we want to make sure that we apply thread synchronization. So we would have accuracy in data. Any questions? And then for 11, it asks you, what happens when the acquire blocking method is called? All the threads run synchronously, and it's gonna make one thread can execute the critical section each time. So it puts it into the sequential mode. And you saw that in our example that we just looked at. That while loop was the critical section, and then so your thread A had to finish before thread B, right? Finish with the loop. Okay, so next we're going to talk about container for threads. Any questions so far? All right. Okay, so in this portion, we're going to touch on how we can manage our threads. And to start, we're going to talk about the data structure for our threads. So queue is a abstract data structure. It's a way that we can put different elements together in a specific order. So it is a container. Now, the way queue works is that when you add elements, it's going to add it at the end of the queue. So it's going to be in queue, right? So this is the back, it's going to be in queue. And then when you remove the element from the queue, it's going to be DQ. So it's going to move from here, right? It's like getting in line, and then so the last person is going to be in the back, and then the first person is going to leave to make room. So in the first in, first out, right? If I'm first in line, I'm going to exit that line first. The elements that added first gets removed first. So it's FIFO. It is not like a stack structure. Okay, it's different. So the queue, the last one is going to be in the back of the line. The first one's going to exit the line. So if we get rid of all the elements, then the queue is empty, of course, and it says that there will be no way to remove further elements. So the queue, it is flexible and it's adjusted so it dynamically modified the size based on the capacity, which is the number of elements that it's going to hold. And Python has a module called queue. So when you use the library, it will be queue, and then you would use its class, which is queue. It's superclass. So we can use it to create a queue that holds a certain number of elements, and we can utilize some of the method to be able to work with our queue. Okay, so when you use the get method, it's going to return the next element of the calling queue object, and it removes it from the calling object. For the put, we want to add new element to the calling object. So get, right, it's look at the next element of the calling object and remove it. Put, it's going to add the new element to the calling object. Then you use queue size, that's going to return the number of the element. Same thing like when you use size of for C++ and array, right? Queue size just tell you how many elements inside that container. Empty checks if your queue is empty or not. Full, check your queue is full or not. So it would return true or false for both of these. So here I want to highlight this because you can implement queue to hold your task, which are your threads. So what we can do is we can create a pool of thread. Okay. But it will not hold any information regarding the task that's executed. So instead of the task that's stored in queue, what we can do is we can have the items in queue to be fed as individuals of the thread pool. So for any given task that's completed by each of the worker in the pool or each of the thread in the pool, what you would see is that your task queue must contain the elements that's processed. So when you look at this picture, you would see that we would have a group of our task, and it's going to feed into another container that contains the thread. Okay, so simply we have two containers working together. And as we access each of the index, we would feed the task into a specific thread index like this. And then together, it's going to complete the task. Okay, so with that, we should answer the next one, number 12. So a queue is an abstract data structure for a collection of elements that is in specific order. And it can be used as a structure containing a pool of threads that represents task queues. And the item of the queue can be fed to individual members of the thread pool. So it is a container that is used to feed into your thread pool. Okay, and that container would be containing your task. Okay, any question? All right, so for the queue, let me come back to the notes here. So this is the expanded example of what you see with your prime numbers using Q. Okay, so let's open what we did for already. Okay, so for example 5, we updated the other programs, right? We saw how this program transitioned through stages. Previously, we added the thread. Now we're going to add the thread queue. So here we're going to import the module called queue. And of course, we're using threading and time like before. The first part of the program here is exactly the same as what you've seen before, with the init function and the run under my thread class. Then you have a function called process queue, and this is the loop. So we would say while true, we're going to do try and except and else here to handle the exception. Because when you're working with threads, sometimes there might be errors or some kind of, so we need to handle that exception there. So we would say try, and for your X, it's gonna be myQ.get. Okay, so we're going to obtain our Q, and we don't want a block, so block is false. So that's gonna apply the 0 there. And then except Q is Q.empty, it's gonna return. So recall that when we say get is when it returns the next one and then it removes, right? So when it is empty, it's going to return. Else, if it still has something in there, we're going to print. So we're going to do print factors of X. We're going to make it sleep for 1 second. Now, since we call print factors here, we need to define it here. Okay. So we would have our variable result string, and that's just simply for our print positive factors R. And then we would have the loop. For I in range, we would have a start at 1, and then we would have X plus 1 as the increment. If X mod I is 0, result string is going to be adding the index of string. So we parse the index value into string so it can display. And then we would show the result string, and we would increment for that, and that will be, we would multiply that by 20. We will print the result string. So our input would be 1, 10, 4, and 3. Now here's the Q part. So you had stated my Q up here, right? Now we're going to define our object for the Q. So my Q as an object, and it is using the Q library and the method. And we want to loop the input. So for X in input, it's going to put, so it's going to add, right, each of these for the input. Then we would have 3 threads. So now we're going to create that 3 thread object. So thread 1, thread 2, and thread 3, A, B, and C. And we would start those together. We would join them together. And then lastly, we will print done. Okay, so here's our output. it starts thread A, and positive factor of 1 is 1. Start thread B, factor of 10, second element, right, is 1, 2, 5, and 10. So as the value gets bigger, you can see that it needs to be able to, right, give you the factors there in groups. So therefore we have to append it to a container so that way it can retrieve it. Then thread C, positive factor of 4 is 1, 2, and 4. And then lastly, positive factor of 3 is 1 and 3. So as it finish out, we're going to exit. So B is going to get removed first, then C, then A. Okay, because B entered first. So then we're going to finish. Now this shows you that it is out of order, even though we start them together, right? But as B was get first, because it entered the task queue first. So it leaves first, and then C, and then A. Okay. Any question? Okay. So that is the part of our notes, and then let's proceed to the next one. So the last part, so for 11, I just want to highlight how we can implement the with statement in threads. So with statement is useful. We can use it to access files. We can use it to access resources. So this is a way that we can manage the resources for parallel programming. So in this example here, you would see that we can loop through, right? Like let's say that I have 500 or 254 files, and I would have a list to store files. And then as I loop through 254 files, I would append it into this list. So I would open, right, and then write, and then put it into the container. Okay. So here you can see that there are ways that you can add, right, each of the file as you loop through. So this is one way. Method 2, you can use F as an object, and we would use an open method to access. And those of you who know, and you know how to use Python file access, this is how you do it, right? And then you would write. And so we would say files that append F, and then we close the file. Okay. Or we can use the third method, which uses a with statement. So with open, okay, and it's going to access the file. It's going to do the write as F, and then we can append. All three of these is going to accomplish the same thing. Okay. So that means that we can just simply write a loop and have it loop through each of the file and be able to append it. We can also implement another loop, and we create the F object and use the open method to access the file and then append it and then close the file. Or we can loop through, and then we would use with open, which is very similar to this, right? Instead of defining F as an object here, we would say with open and the file, right? And then write as F. So it's going to treat whatever that's open file is going to be F. So same thing, it's just using the with statement here. And then as we access it, we would append it. Now, the practice is that if you open it, append it, you need to close it. So you should close it, right? But They all use open method. They all use append method. It's just 3 different techniques on writing it. So for example 4, I screenshot this part here so you can see that when we create the lock, my lock, right? We can say my lock. Let me pull that up for chapter 11. See if it's, oh, there it is. Okay, example 2. All right, so here's the mylock object. We have a function called get data from file version 1, and then we pass file name. So as we create the object here, we would use acquire. We talked about this method. So we would start the lock, and then we would write the with statement. So with open file name, and it's going to read the file as F, and as it read it, it's going to append the data. So once we finish, we release the lock. Okay. Now this is going to be for your lock, so it induces the deadlock. Then to handle any kind of exceptions, potential errors, you have another function called get data file B2. And unlike the other, now you are going to use mylock. So it would say with mylock, open the file, read it as F, and then append. So you can do it this way where you acquire the lock and then open the file and read it and then release the lock. So if you acquire the lock, you must release the lock. Okay. And in this one, what we did was we used a with statement. You would say with my lock. So it's going to lock it while it's open the file and read it and append it. So then we need to append it to our data list. Okay. So in this one, right, as it completes it, we don't need to release it then. So just 2 strategies on how you can do that. Okay. Then we have a try and accept get data. So now we're going to call the get data from file B1 and then our text file. Right, we pass the actual parameter for the file. Then for exception handling, we would say accept file not found error, and we just display file cannot be found. Then we would have lock acquire and then print. Okay, so this shows you how you can implement your lock. And first you have to create a lock object. Then if you're using your lock, you can acquire your lock. When you're done, you release your lock. Or you can implement it with your with statement. So whenever that you create your lock object, you can always use acquire to induce your lock. Okay. So now when we print, right, we can say that lock can still be acquired until it's released. So a lock is utilized in different stages in your program for different threads. So as you would use the lock, make sure that you block the others from accessing the resource. Once your thread is done, you release your lock, and that allows the program or the interpreter to pick up where it's left off, and then until that lock is induced again. So once the program is picked up after it's released, it could be any of the other threads to be able to jump in and be able to begin. or complete the task. So sometimes you have to go through and set up the lock multiple times. In the case where if you want certain thread to only execute the critical condition at that point in your program. Okay. So this needs to be manually controlled when you're using multi-thread, and that's important takeaway. Okay, and in this example, it also shows you how you can handle exception in the case where if, you know, for some reason it cannot access the file, you don't want it to stop right there. So you need to do the exception handling like that. Okay, so we can run this, right? As I don't have sample 0.txt, it tells me file cannot be found. Now, if I put in the file there, right, it's going to be able to read it and append it. So okay, so that's an example that you can see. So when you write the with statement, you start with the keyword with, and then you add the expression and your target, and then anything following. Okay. And you can have multiple expressions and targets. So the nice thing about Python is you don't have to repeat the same thing. You can just write it all across in one line instead of doing multiple with statements. So you can have multiple expressions. Okay, so I put in your resource for you. So in case you haven't used this extensively, you can check out compound statement documentation from Python. And they also provide additional example for you to see there. Okay, so now let's try the last one. Okay, so refer to the notes and examples, write the with statement to open the file sample text. And that's easy. You can say with open, then your sample text, which is your file name. And when you use a W here, that's to write. Okay. And then SF. So anything you want to name it here as file, as, you know, whatever object name that you want to give it. And then we want to append the data. So we can say data append, and then data would be a list, right? So you have to define what data is. Like that. Okay, so this is one way that we can write our compound statement. Okay, we will open the file and write it. And we would append the data into the container. And so as you can see, this is not the only way that we can write this, right? We can write it as the other two options as shown in your examples. Any question? Okay. All right, so that concludes the assignment for this week. We do have a lab on Thursday. So for our lab, we will work with this a little closer so that way you can have a little hands-on programming for our lab exercise. Any question regarding chapter 10 and 11? 11 is pretty short, so. All right, so in the next few weeks, we would continue, and then we will talk a little bit more about, like, you know, race condition, exception, and then also patterns when we get closer to the end. I will do a final review session. I want to say either a week or the prior week So maybe like 14 or 15. This class have a lot of content, so we might have to cover final review in the maybe on a Tuesday in week 15. That gives you like about a week to kind of look over. The final exam is going to be multiple choice, but you do have a project that needs to be submitted at the end of the semester. And then I will try to put in the prior project from the other class that completed last year, so you can see what they've done, and then you can get some kind of ideas on what you want to do. Okay, so I'll share that resource throughout this week maybe. Okay, so go through, check out your notes, and then look at the example. And then for the lab this week, let me come back here. We are gonna we are gonna work with yielding. We're gonna do single thread and multi-thread programs. They're really short programs anyways. So again, I will demo this in Linux, but you can run it in your IDE. I don't think it's required to do Linux. If you have all the proper module, you can run it in your IDE. Okay. So we would create like multi-threads, pass arguments in thread, and then we would use thread for IO. So you can see how that's done. And then we also implemented like so for IO, it will be like files. Okay, so we will be able to generate files and like multiple test files. So that's pretty cool at the end. So you can see how we can automate like file creation. And then we will do a programming queue. So unlike the other lab, this one's a little longer because last week lab was really short. So I want to focus on this more because if you understand how to do this, this is a really important core for our concept for Python programming. And then when you add that to your resume, and you can show some of your sample of your work through GitHub or something like that, that can be very impressive, okay, for development. All right, so let me stop recording.